Hey everyone, and welcome back to CIPET Polymer Tech. I am seriously thrilled you're joining us today because this explainer is absolutely essential viewing. If you're a production engineer, a quality control analyst, or maybe an R&D engineer, you are exactly in the right place. Today, we're unpacking a total masterclass on Masterbatch troubleshooting and root cause analysis. We're drawing directly from industry best practices here to elevate your problem-solving skills to a whole new level. Okay, so picture this. You're right in the middle of a massive production run. The machines are just humming along, everything seems totally fine. And then, suddenly, the phone rings. It's a huge customer complaint. Your mid-production batches are failing. The shade has completely changed, there are black specks literally everywhere, and you're getting awful played out on the die. Panic sets in, right? An amateur in this situation just starts scrambling. They start randomly changing machine settings, sweating through their uniform. But a professional engineer, they stay completely calm. They don't panic. They investigate. All right, let's dive into this agenda real quick and see how we're going to transform you into a scientific problem solver. First, the troubleshooting golden rule. Then, we'll solve common masterbatch defects, followed by a real industrial case study, the RCA and CAPA framework, and finally, a quick summary. Moving into Section 1, the troubleshooting golden rule. Stop and ask before changing the formulation. The absolute biggest rookie mistake you can make on the factory floor is blindly changing the chemical formulation at the very first sign of trouble. You see a defect and your brain instantly goes, oh, add more of this, reduce that. Just stop right there. Before you tweak a single chemical ratio, think of me as your mentor for a second, guiding you through your first line of defense. You need to ask yourself these 5 diagnostic questions. Number 1, has the raw material changed? Number 2, did the pigment lot change recently? Number 3, were the machine settings altered by anyone on the floor? Number 4, has there been a shift change? Like, is there a new operator running their line? And finally, number 5, have the ambient conditions, like your temperature or humidity, drastically changed? Here is the crazy part. Asking just those 5 simple questions will successfully diagnose a staggering 80% of your manufacturing problems. Literally 80%. So before you spend hours reformulating back in the lab, just do a 5-minute investigation on the floor. It can pinpoint the exact variable that shifted and caused your defect in the first place. Okay, Section 2, solving common masterbatch defects. This is a diagnostic guide to the top 5 issues. Now, what's really interesting about this next part is how we tackle that remaining 20% of problems that actually require some deep digging. Let's step into our rogues gallery of defects. First major problem. Shade variation. The symptom here is super obvious, right? Batch 1 is perfect, batch 2 comes out way too light, and then batch 3 is suddenly super dark. What is causing this? Well, root causes usually point to pigment strength variations from your supplier, maybe incorrect manual or auto-dosing, melt flow index variations, or just severe temperature fluctuations in the barrel. Now, the scientific solution here isn't to just blindly throw more pigment into the mix. You need strict incoming pigment quality control, rigorous calibration of those auto-dosing units, and total process standardization. Moving right along to problem 2, black specks. You're holding your beautifully molded parts and bam, there are these random, ugly black dots. It is incredibly tempting to just blame the raw material here. But honestly, often it's burnt polymer hanging out in barrel dead spots or simply poor machine cleaning between runs. To actually solve this, you need aggressive, proper purging protocols, regular physical barrel inspections, and strict temperature optimization so you aren't just scorching your polymers right out of the gate. Next up, problem 3, poor dispersion. This usually shows up as color streaks, an uneven overall shade, or these really concentrated pigment spots. This is almost always a mechanical or compatibility failure. You're likely dealing with low shear forces, maybe a poor screw design that just isn't kneading the material properly, an incompatible carrier resin, or processing temperatures that are way too low to melt the carrier effectively. Your solutions? You've got to step up that mixing efficiency. Optimize your screw RPM to generate the right shear, and absolutely always double-check your carrier resin compatibility. All right, problem 4, played out and dye buildup. So what actually is played out? It's basically when you start seeing these chalky, white, or oily deposits building up right on the machine die or the mold surface itself. It is a total nightmare for continuous production. And why does it happen? Typically, it's an excess of internal or external lubricants, or maybe using low-quality additives that just can't handle the heat. It could also be running your processing temp too high, or general additive migration. To fix this, you have to optimize your additive package. Definitely pull back on excessive lubricants. Maintain a really strict dye cleaning schedule, and keep a hawk's eye on your temperature profile. And wrapping up our defect gallery, we have problem 5, bubble formation. Symptoms here include internal voids, surface bubbles, or those tiny pinholes in your final product. The usual suspects? Well, moisture is absolutely public enemy number 1 here, but it could also be volatile contamination or polymer degradation creating off-gassing. The solutions are pretty straightforward but totally critical. Ensure proper, thoroughly timed drying of your resins, utilize vacuum venting on your extruder if you have it, and conduct really meticulous incoming material inspections. Let's move into section 3, a real industrial case study. We're calling this one the false suspect. Okay, so we know the theory, right? But let's step out onto the actual factory floor for a minute. Imagine a severe customer complaint comes in. A premium white Masterbatch is suddenly producing these sharp black dots on bright white molded parts. The pressure is on. Production halts. Literally, millions of rupees are on the line. And this brilliantly illustrates the danger of jumping to conclusions. First, think about the assumed problem. Everybody, and I mean everybody, blamed the titanium dioxide quality. They just assumed the incoming batch was contaminated. But our professional engineer? They didn't panic. They investigated. They checked the TiO2. It was perfect. The formula? Perfect. The processing parameters? Flawless. So they dug into the actual problem. Turns out the injection molding machine had run an old black compound 3 days prior, and it was never properly purged. Those dead spots were slowly releasing carbon black right into the pure white Masterbatch. So the fix wasn't to call the TiO2 supplier and scream at them. The actual solution was improving the machine cleaning protocol on the shop floor. Once they did that, the customer complaints permanently stopped. Seriously, write this down, highlight it, drill it into your memory. Not every defect is a formulation issue. Do not touch your chemistry until you have completely verified your machinery and your processes. Which brings us nicely to Section 4, the RCA and CAPA framework. Formalizing the detective work. Top-tier professional companies do not rely on guesswork. They don't use gut feelings, they formalize their detective work. Let's see how this builds the absolute foundation of industrial problem solving. Root cause analysis, or RCA, is a non-negotiable 6-step process. Step 1, clearly define the exact problem. Step 2, collect objective data straight from the floor, no opinions allowed. Step 3, list all possible causes without any bias. Step 4, systematically eliminate options until you identify the actual root cause. Step 5, implement your scientific solution. And crucially, Step 6, verify over time that the problem does not return. Now, once you actually find that root cause, you apply CAPA, Corrective and Preventive Action. Corrective action is essentially putting out the fire. It's solving the problem that happened today so you can get production running again immediately. But true engineering magic, that happens with preventative action. That is fireproofing the building. It's putting systems in place to ensure that the exact same problem never, ever happens again in the future. Let's make this totally concrete with a really quick example. Imagine you have an issue where the wrong pigment shade was used. Your corrective action is immediate, right? Quarantine the bad product and replace the faulty pigment batch on the line right now so the customer gets their order. But your preventive action, that's structural. You go back, you strengthen your incoming pigment quality control checks, and you completely overhaul your supplier approval system so a bad batch can never even make it through your warehouse doors again. And that brings us to Section 5, Summary and Next Steps. Getting ready for the grand finale. We have covered a massive amount of ground in this explainer today. You have conquered the diagnostics for 5 major Masterbatch defects. You've seen the power of asking the right questions before changing a formula. And you've learned to apply the RCA and CAPA frameworks like a true pro. You aren't just reacting to problems anymore, you are scientifically eliminating them. And all of this preparation, it leads us to tomorrow. Tomorrow is day 30, and it is our grand finale. We are going to walk through the entire Masterbatch R&D workflow, from the second a customer inquiry hits your desk, through sample analysis, pigment selection, formulation, lab trials, QC, all the way to commercial production scale-up. We'll even be discussing career roadmaps in color matching. It is going to be the most valuable session we have done yet. If you're ready for it, I want you to drop down into the comments right now and type Day 30 Grand Finale ready. As we wrap up, I really want you to internalize the core mindset of a true professional in our industry. A successful engineer doesn't hide a problem. They find its root cause and solve it permanently. So, I'm going to leave you with this final thought today. Are you ready to stop simply reacting to daily defects and start actually eliminating them at the root? If you found value in this breakdown today, please hit that like button, share it with your team, and make absolutely sure you subscribe to CIP Polymer Tech so you don't miss our massive grand finale tomorrow. Keep questioning, keep solving, and I will see you in the next one.
Before you leave, let me tell you a true-to-life industrial story that every quality engineer, production engineer and R&D engineer should be here. It was 2:15 am in Masterbatch manufacturing plant. Production was running continuously and everything looked normal. Suddenly, the customer phone call came. Your black Masterbatch is failing. The molded part don't match. Yesterday said production has stopped. Within minutes, panic spread across the factory. Production blamed QC. QC blamed R&D. R&D blamed raw material. The purchase teams blamed the pigment supplier. The operator blamed the machine. Everyone had an opinion, but nobody had the real answer. The company was losing thousands of dollars every single hour because every machine on the customer line was standing still. The plant manager walked into the meeting room and said just one sentence: "Stop blaming people, start finding the root cause." That's when the RCA, root cause analysis team, was formed. They did not guess, they did not assume. They collect sample from every stage: raw material, pigment, carrier resin, additive, extrusion processing, cooling line, pallet inspection, and finished product. They checked MFI, they checked moisture, they checked dispersion, they measured delta E, they reviewed the production log. They even compared shift-wise machine parameter. For 6 hours, every possibility was investigated. Finally, they found something nobody expected. The pigment was not defected. The machine was not fault. The formulation was correct. The real culprit was a tiny temperature sensor inside the extruder. The sensor was showing 200 degrees Celsius, but the actual melt temperature was nearly 220 degrees Celsius. That extra heat particle degrade the polymer and change the pigment dispersion. The color shifted, the gloss reduced, customer complaint started. One smell sensor cost lakhs of rupees in loss, but the factory story doesn't end there. The company didn't just replace the sensor, they implemented CAPA, Corrective and Preventive Action. They calibrated every temperature sensor. They updated the prevent maintenance schedule. They trained all operators. They introduced hourly parameter verification. They added a final delta E approval before dispatch. And most important, they document everything so the same mistake would never happen again. That is the difference between an ordinary factory and a world-class manufacturing company. Remember this: every defect has a root cause, every root cause has a solution, but only engineer who asks why instead of WHO become real problem solver. So the next time you see poor dispersion, black speck, color variation, high MFI, no strength, moisture defect, customer complaint or machine instability, don't panic, don't blame, follow the RCA process, implement CAPA and solve the problem permanently. In the next master class, we will solve another real industry case from the plastic and masterbatch industry, step by step, exactly like professional R&D and quality team do in top manufacturing company. Subscribe now, because here we don't just teach plastic, we teach how real engineer thinking investigated and solved problems that save companies millions. Thank you.